The layer of gases that surround the Earth, atmosphere. The atmosphere is a mix of gases like oxygen and nitrogen that surrounds our planet, protecting life and helping regulate temperature. Imagine trying to keep your house warm during a chilly winter's day. Just like how your home's walls and roof trap warmth inside, the Earth's atmosphere acts as an insulating blanket, keeping our planet at a stable temperature. The layers of gases surrounding the Earth, much like the layers of insulation in your home, prevent essential heat from escaping into space, ensuring a livable environment for all life forms. The layer of the atmosphere closest to Earth's surface, troposphere. The troposphere is where all the weather happens and where we live and breathe. Imagine trying to find your keys in a messy room where everything you need is always at arm's reach, but things tend to get cluttered and mixed up. The troposphere is similar to this because it's the closest layer of the atmosphere to Earth's surface, where all the weather activity and most of the air we breathe are concentrated, much like how daily essentials are scattered around your room. Just as your room is the space where most of your day-to-day activities happen, the troposphere is the atmospheric layer where most of Earth's weather and life-supporting processes take place. The weight of the air pressing down on a surface, air pressure. Air pressure is the force exerted by the weight of air molecules on a surface. Imagine you're at a crowded concert, trying to move through a dense crowd to reach the front. Just as each person in the crowd is exerting a force against you, making it difficult to move, air pressure is the weight of air molecules pressing down on a surface. In both situations, the force exerted by each individual, whether a person or an air molecule, accumulates to create significant pressure, making it challenging to move forward, or, in the case of air pressure, to lift against it. The amount of water vapor in the air humidity. Humidity is how much moisture is present in the air around us. Imagine trying to fit all your clothes into a suitcase that seems just a little too small. Just like the suitcase has a limit to how many clothes it can hold, the air has a limit to how much water vapor it can contain. Humidity is like the fullness of that suitcase. The more water vapor in the air, the closer it is to being full, just as a suitcase gets heavier and harder to close as you pack more clothes into it. An instrument that measures air pressure. Barometer. A barometer is a tool used to determine atmospheric pressure, helping forecast weather changes. Imagine you're trying to determine if it's going to rain by feeling the heaviness of the air around you. This is similar to how a barometer works, as it measures the weight or pressure of the air. Just as you might feel the air getting heavier before a storm, a barometer detects changes in air pressure to predict weather patterns, with the air's weight acting as a clue, much like the way your senses perceive the heaviness in the atmosphere. The transfer of heat energy from a warmer area to a cooler area in a liquid or gas. Convection. Convection is the process where warm air or liquid rises and cooler air or liquid sinks, creating a cycle. Imagine you're at a party and the room gets crowded, so you move to a less crowded area to feel more comfortable. This is similar to how heat energy moves in liquids or gases, where it travels from a warmer, crowded area to a cooler, less crowded area. Just like you seek out space to feel more at ease, heat energy seeks cooler areas to balance out temperature differences, creating a flow that we call convection. The average weather conditions of an area over a long period of time. Climate. Climate is what you expect in terms of weather patterns over many years in a specific region. Imagine trying to figure out someone's personality by observing them only on a single day. Just like a person's true character is revealed by their consistent behavior over time rather than by their mood on any given day, the climate of an area is understood by examining its weather patterns over a long period, not just a single day. In this analogy, the single day is like a short-term weather event, while the long-term observation of mood and behavior parallels the study of climate, which requires looking at average weather conditions over many years. A huge body of air with similar temperature and moisture throughout. Air mass. An air mass is a large volume of air in the atmosphere that has uniform temperature and moisture. Imagine opening your closet and finding all your clothes are the same color and fabric, making it easy to decide what to wear. This is similar to how an air mass functions, as it is a large expanse of the atmosphere where the temperature and moisture levels are uniform throughout. Just like your closet full of identical outfits provides consistency and predictability in dressing, an air mass offers a consistent weather pattern over a large area, as it maintains the same temperature and moisture characteristics throughout, much like the uniformity of your clothing. The boundary between two air masses of different temperatures is called an air front. An air front is where two different air masses meet, often causing changes in weather. Imagine you're at a crowded party where half the room is filled with people who love dancing and the other half with people who prefer sitting and chatting. Just like how the dancing enthusiasts and the chatty sitters create a noticeable divide at the party, an air front is the boundary where warm, energetic air masses meet cooler, more stationary ones. In this analogy, the dance floor represents the warm, active air mass. The sitting area symbolizes the cooler comet, calm air mass, and the boundary where they meet is the air front, much like the line dividing the dancers from the sitters. A storm with lightning and thunder. Thunderstorm. A thunderstorm is a weather event characterized by the presence of lightning and its accompanying sound, thunder. Imagine being at a party where two people are having a heated argument, and everyone around is tense, waiting for it to escalate. Just like how the tension in the room builds and finally erupts into loud voices and dramatic gestures, a thunderstorm forms when atmospheric tension builds up between warm, moist air and cooler air above, eventually releasing its energy as lightning and thunder. In this analogy, the warm, moist air is like the initial disagreement. The cooler air represents the opposing perspective. The building tension is akin to the rising atmospheric instability, and the outburst of the argument is similar to the dramatic release of energy through lightning and the sound of thunder. A spinning funnel-shaped column of wind, tornado. A tornado is a powerful rotating storm that extends from a thunderstorm cloud down to the ground, causing intense wind and damage. Imagine trying to untangle a mess of earphones that have been shoved into a pocket. Just as those earphones twist and turn into a chaotic knot, a tornado forms when differing wind speeds and directions cause air to spiral into a tight rotating column. The tangled earphones represent the swirling winds, with each loop and twist akin to the tornado's spinning funnel shape, both resulting from conflicting forces, creating a spiraling motion. A large tropical storm with winds of more than 74 miles per hour. Hurricane. A hurricane is a powerful storm system with strong winds and heavy rain that forms over warm ocean waters. Imagine you're trying to organize a large group of people for a surprise party, but everyone has their own ideas and moves in different directions. This chaos is similar to how a hurricane forms, as warm ocean water fuels the storm, causing individual wind currents to spiral and combine into a powerful system. Just like how the group needs coordination to successfully pull off the party, A hurricane requires these wind currents to align and organize into a cohesive, swirling mass with winds exceeding 74 miles per hour, creating the intense tropical storm. A large rise in water levels caused by hurricane waves and winds. Storm surge. Storm surge is the abnormal increase in seawater level during a storm due to strong winds. Imagine trying to carry a stack of papers across a windy parking lot. Just as the wind can lift and scatter your neatly piled papers, a hurricane's powerful winds and waves can push vast amounts of ocean water ashore, leading to a storm surge. In this analogy, the papers represent the water in the ocean, and the wind in the parking lot acts like the hurricane, forcing the water to rise and flood areas that are normally dry. A storm of swirling air with a low pressure center. Cyclone. A cyclone is a large, powerful storm system with strong winds rotating around a central low pressure area. Imagine you're at a crowded party and someone drops a tray of snacks in the middle of the room. Just like people rushing toward the snacks create a swirling crowd, a cyclone forms when air rushes toward a low pressure center. In both cases, the movement is driven by the attraction to the central point. Hungry guests seeking food at the party mirror air molecules moving toward the low pressure area, resulting in a whirl of motion around that core. The atmospheric conditions at a specific time and place, like raining and cold. Weather. Weather is the state of the atmosphere at a particular time and place, including temperature, humidity, wind, and precipitation. Imagine standing in front of your closet in the morning, trying to decide what to wear based on the day's plans. It's similar to checking the weather, where you assess what's happening outside, such as rain and cold, to prepare accordingly. Just as you consider the day's events, like a meeting or a casual outing, to choose your outfit, you look at atmospheric conditions like precipitation and temperature to decide if you need a raincoat or a sweater, highlighting how both scenarios involve evaluating current conditions to make practical choices. Air movement caused by pressure differences. Wind. Wind is the movement of air from high pressure areas to low pressure areas. Imagine you're in a crowded room and someone opens a door to a quieter, less crowded hallway. This is similar to how wind works, because just like people naturally flow towards less crowded spaces, air moves from areas of high pressure to areas of low pressure. In both scenarios, the movement is driven by pressure differences. People are pushed by the discomfort of the crowd, while air is pushed by atmospheric pressure imbalances. The flow of air from the sea to land in the daytime. Sea breeze. A sea breeze is a cool wind from the ocean that moves toward the land when the sun heats up the land faster than the water. Imagine you're at a crowded concert and everyone rushes towards the stage when the main act comes on. This movement is similar to how a sea breeze forms, as air moves from the cooler sea towards the warmer land during the day. Just like the concert goers moving towards the excitement, the cooler air from the sea rushes in to replace the warm rising air over the land, creating a flow from sea to land. The flow of air from land to sea. Land breeze. A land breeze is when cooler air from the land moves toward the sea, usually at night, due to the temperature difference between the land and water. Imagine you're at a crowded concert and everyone decides to leave at once, creating a rush towards the exit. This is similar to how air moves from land to sea during a land breeze. Just as people flow from the crowded space, land, to the open area, sea, to find balance and comfort, cooler and denser air from the land moves towards the warmer, less dense air over the sea, seeking equilibrium. Water that falls to Earth in any form, like rain, snow, sleet, or hail. Precipitation. Precipitation is when water from clouds falls to the ground as rain, snow, or ice. Imagine you're at a party with a variety of drinks being served, but you're not sure what you'll end up with in your glass. Just like the uncertainty of which drink you'll receive, precipitation involves different forms of water falling from the sky, such as rain, snow, sleet, or hail. The connection is that just as a party guest might receive any beverage from the selection, the Earth can receive any type of precipitation depending on the atmospheric conditions, with temperature and air pressure acting like the bartender deciding what gets served. The process of a gas changing into a liquid. Condensation. Condensation is when water vapor in the air cools down and turns back into droplets, like on a cold glass. Imagine trying to fit too many clothes into a small suitcase before a trip. As you pack, the clothes get compressed and squeezed tightly to fit into the limited space. Much like gas molecules cool down and come closer together to form a liquid. Just as the clothes change from a loose pile to a compact bundle in the suitcase, gas molecules transition from a freely moving state to a denser liquid form during condensation. The top of liquid changing into a gas. Evaporation. Evaporation is when a liquid turns into a gas, usually from the surface, when heat causes its molecules to move faster and break away. Imagine sitting in a crowded room, and gradually people start leaving one by one, making the room feel less congested. This is similar to how molecules at the surface of a liquid gain enough energy to escape into the air as gas, reducing the overall density of the liquid at the top. Just like people leaving a crowded room makes it less crowded, molecules escaping from the surface of a liquid into the air make the liquid level decrease, illustrating the process of evaporation.